Let's look at one more example of using this augmented matrix and row reduction process to solve a system of equations. So let's solve this system. It's a two-variable, three-equation system. So when we write down the augmented matrix for this system, we get, let's see, 1, 2, 3, minus 3, 2, 1, 4, minus 1, 2. And now we need to row reduce. So fortunately, we already have a 1 in this upper left-hand corner. So we just need to do row operations to use this 1 to zero out the stuff below it. So we're going to do row 2 plus 3 times row 1. That'll get rid of the minus 3. And then row 3 minus 4 times row 1. And that'll get rid of the 4 there. So first row doesn't change, 1, 2, 3. Second row, so minus 3 plus 3 is 0. And then 2 plus 3 times 2, so that's 8. And then 1 plus 3 times 3, so 10. And then third row, minus 4 times first row, so 0. And then minus 1, minus 8, so minus 9. And then 2 minus 12 is minus 10. Okay. Now we need to, right, so this second column, our second row, we need to make its leading 1 appear. So this 8, we need to make that a leading 1. So we're going to do row 2. We're going to multiply that by 1 over 8. So first row doesn't change, 1, 2, 3. Second row is now 0, 8 divided by 8, which is 1, and 10 divided by 8, which is 5/4, I guess. Okay. And then last row doesn't change, so 0, minus 9, minus 10. Okay, now that we have a leading 1 in this pivot position, we can use it to eliminate the minus 9 below it. So we're going to do third row plus 9 times second row. This doesn't change the first row, 1, 2, 3. Doesn't change the second row, 0, 1, 5 over 4. And now last row is 0, so minus 9 plus 9 times 1 is 0, and then minus 10 plus 9 times 5/4. So let's see, minus 10 plus 9 times 5/4, that's 45/5. Right, so this is 50/5 minus 50/5 plus, sorry, fourths, not fifths. Okay, so minus 40/4 plus 45/4 is 5/4. Okay, I think I did that right. All right, so there aren't any there aren't any columns, any variable columns that aren't pivot columns, so we aren't going to get a solution that has a free parameter. So we don't need to go all the way to reduced row echelon form, right? We could just do back substitution. But notice this last row. This last row has a bunch of zeros, and then in the augmentation column a 5 over 4. So this equation, the equation that this row represents, says 0 equals 5 over 4. Well, clearly there's no solutions for that. So this whole system has no solutions. In fact, we probably should have expected that from the very beginning, because the system that we started with has more equations than variables. And usually, not always, but usually, when you have more equations than variables, you end up with no solutions.